Today we're looking at how to use the MicroBit Radio. We're going to learn how to set a radio group. We're going to learn how to send and receive information. We're going to look at two different examples of using the radio. I have our first example here already made. This is to hopefully speed up what would otherwise be a somewhat complicated build. The first thing I'd like to point your attention to is on start. Radio set group 1. You can have your MicroBit communicate from 1 to 255 different channels. If your MicroBit is listening on channel 6 and someone else sends on channel 6, you will have the opportunity to receive that. But if you're sending on channel 6 and your friend is on channel 128, then your friend will not receive that information because the MicroBit is not listening on that channel. So setting your group is important. If we click radio, we see we have a bunch of blocks that we can use. We have our radio set group. We have the ability to send numbers, send strings, and then various things we can receive. I created a radio send string and the word Marco. This is a Marco Polo game. The other part I need is on radio received. And when you make it on radio received, you're going to notice that under variables, there is no variable that looks like radio string or received string. That's because this variable only exists in this block. So if you drag that down into show string, now it can show it. When I press A, it's going to wake up our emulator and it's going to give us a second MicroBit. When I press A again, it should send the string Marco. And when it receives that, it should show us it. It's important to know that this first MicroBit only needs the on-start block and the button A pressed. It doesn't need this block. And the second MicroBit actually only needs the on-start radio group set and the received string. It doesn't need the on button A press. But if you put all of the program on both of the MicroBits, that means both MicroBits can send their word Marco. That's pretty neat. But my favorite part of the Marco Polo game is the how far away someone is, trying to guess how far away they are by the sound of their voice. This could be a little complicated how to use this next block, so I made a little presentation to help us out with that. This is a plot bar graph block. This is from our LEDs. This is one we've not used before. The plot bar graph of this is the number we want to graph up to, and this is the range. This is the biggest possible number it could be. Make it more obvious, I have an example. If I have a bar graph, please plot me 0 out of 5. It's going to give me one little dot. If I want to ask you to graph 3 out of 5, the MicroBit will fill up part of the screen. And 5 out of 5, that's the biggest number it could be. It's going to fill the entire screen. This is a great, not very accurate, visual reminder of how something is doing. So we have an ability to graph how far away someone is, but how do we know? Well, we have this received packet signal strength. This is under the radio tab. And you can click this drop down and get a few other options. Now, a packet is how a computer bundles information together to send it. Imagine you were passing a note in class. The folded up note would be the packet, and when you unfold it, that information inside is the message. This is a little weird though, because the weakest possible number that our packet could be and still be received is -128, where the strongest it could possibly be is -42. Those are some weird numbers. I'm not sure why that's how they chose to report it out, but I do know that that's not going to work for our bar graph. Up to -42 is not going to work. It wants a positive large number, and it wants the smallest possible to be 0, not -128. I have created a, this is something you might have seen from math class. It's like a function table. We need to get from x with its lowest possible being of negative 128 to the function of x of being 0. So the lowest is going from negative 128 to 0, the highest from negative 42 to 86. What could we possibly do? Let's look at a number line. If I want to get from negative 8 to positive 17, I need to do something to my number. I need to add to it. If I want to get from my range of negative 128 to negative 40 whatever, I need to get the lowest possible one to 0 and the highest to something else. I need to add to it. As you may have spied if you were paying close attention, we need to add 128, and that makes sense. How do we get from a negative 128 to 0? Let's add 128 to it. And when we happen to add 128 to negative 42, we get 86. So weird number, but that's the biggest number we could have. The strongest signal is 86. So I'm going to then come down here and I'm going to drag up this block. So I got the plot bar graph from LED. I got the received signal strength from radio. And I got the adding 128 from math. So my whatever I want to plot, received signal strength plus 128, that should give me something 0 to 86. And was my biggest possible number? 86. So that's my range. Now when I press A, it will once again wake up the emulator. Sometimes, this is a great tip, if it's not working, click the reset button. Press A, that wakes it up. Press A again, and it will send the word Marco, and then it will decide what was the strength of its signal. And as we can see, it filled up big, it got the strongest possible signal. That's because in the emulation, it just assumes it has perfect radio reception. They're hanging out right next to each other. If we are further away, every time you press A, you should see this bar graph get smaller. And of course, this works both ways. So you could have Marco up here, then give you a bar graph as well. Our second example is a very useful way to flex on your friends with how fit you are. Once again, this program is made, and rather than taking you through a painful step-by-step build, I'm going to talk about what's going on. I'm going to hide a few blocks, because we don't need that one yet, and we don't need that one yet. We first just need a functional fitness tracker. Anything that is only created once and set to like a 0 is a great thing for on start. So I'm making two variables, one called jumpy jacks and one squatty squats. Those are both set to 0. That's the beginning of my workout. You can see I've chosen a radio group in here, which will be useful later. On shake, like I'm holding the MicroBit and doing my jumping jacks, I have it change my jumping jacks variable by 1 and then give me a visual feedback. Let's see what that looks like. It gives me a heart. This is useful for the humans using your program. Without this visual feedback, there'd be no indication anything was happening. Then on button A, I have it change squatty squats by 1 and again, give me a visual impact. So I can do some jumping jacks by shaking and some squats by pushing the A button. When we go to radio, we see that we can send our numbers, send our strings, but we can also do the send a string and a number at the same time. This is pretty neat, and that's what's going to happen down here. Down here, I have radio send value jumps and the variable jumping jack. So they want a word. Now this word cannot be more than 8 characters. So I made these ridiculous variables, jumpy jacks and squatty squats, because I wanted to make them something too large to send. So you could be it would be super obvious that I'm not somehow sending this variable name. You can't send the variable name. You, however, could send a label with that variable, and that's what I'm doing. So I'm saying, hey, This value, the word, is jumps. And please send whatever is currently in jumping jacks. Then I repeat, send value squats. And this is the word squats, and send it with the variable squatty squats. Our second microbit needs this extra bit here where it's on radio received. And on radio received, it's got name and value. Now, just like before, these don't show up anywhere over here in our variable tabs. That's because these variables only exist within this block. So the first thing it's receiving is jumps or a word. So I'm going to take the first variable and I'm going to put it into my show string. If I were to try and put in show number, either it's not going to let me or it's not going to work. Value then is a number, so I'm going to put that into show number. All right, I'm going to show you what happens, and then I'm going to take a moment to explain why. I'm going to put a couple jumps and squats in there. I'm going to press B to send it. When I press B again, this receives the word jumping, or jumps and then a value, and then it receives squats and a value. The other microbit only needs on start, radio set group 1, and on radio received, this. It doesn't need access to these three sets of code blocks. And this is a powerful thing here, because this microbit doesn't need to know at all what's coming other than it will be a word and a number. And so I could rearrange these. I could have a whole bunch of these. I could have 10 of these send radio, word, and number. And the only thing on my receiving one is, hey, when you receive this, give me the word and give me the number. Super duper neat. Hope these two examples gave you some ideas of interesting things you might build using the microbit. Before you go, let's briefly talk about things that use radios. Garage door openers use radios, walkie-talkies, cell phones, remote controls, maybe for your TV, toy cars, game controllers, smartwatches. All of these have radios in them which are used to communicate wirelessly. Any things that these do, we might be able to make with our microbit.